You've got some NAs?
Yeah.
Yeah, there are some NAs, yeah. Who thinks they got it? All right, describe your code.
So I have the mean function,
Okay.
and inside the mean function is everything but NA. So summation is dot NA, and then as numeric, because the body mass is character for some reason.
It is?
That's what it was for me.
Penguins, body mass G, class, integer.
Integer.
Okay. Well, I'll let it fly. All right, as numeric.
And then penguins dollar sign service.
Penguins, dollar sign, body mass G.
Yeah.
What's wrong?
You wanted to have it for each species.
I want it for each species. That's for the entire data set. So you gave me the mean body mass G for every single penguin. And let's look at this. Penguins, dollar sign, body mass G. Pipe that to mean, I get NA. But if I say NA remove equals true, 4,201, that actually seems a bit more realistic as the average body mass. Who thinks they've got it for each penguin species? Yes.
So I made a data frame. I don't know if
Okay.
I should do that, but I made a data frame and then did mean and then called the data frame DF. And then in square brackets DF dollar sign species equals a deli.
Okay, so we're gonna subset.
Specifics.
All right, so penguins, dollar sign, species equals add deli, like so. 6.
So I put mean and then I made that data frame.
Okay.
So
NA. So you deleted the NA rows first. That's important.
Mm-hmm.
Okay.
Did that work?
Each of those 3 is what I was looking for.
Each of those 3, right?
All right, so mean of that NA remove equals true. Well, that's not working. Penguins, where penguin species equals a deli, number 6. What did that give us? That really is just the body mass G for the Adeli rows, but this is not a vector, so we can't just say mean. It's a tibble, which is a data frame. It's just a stupid name for it that tidyverse gives us. So that's a data frame. You can tell it's got row numbers. So we can't say mean on that.
I think I got that.
Okay. What approach did you use?
So first I felt about the NAs. So I did penguins, or DF, open bracket, and then not.
Not is NA.
And then DF, $ body mass.
For me, it'd be penguins, body mass G,
Okay.
and then a comma there, right?
Yes. And that's all.
All right, so now I've got a new data frame. It got rid of a few rows where body mass G was NA. So you're getting rid of those to start with, all right?
And then I piped that into group by species.
No, we haven't done that yet.
Oh.
That's what we're learning today.
So, exclamation point means not, right?
Mhm.
But what is NA mean?
It means, is it NA?
Okay.
And so not is it not NA?
Okay.
So we're going to keep all the rows where penguin's body mass G is not NA. All right, let's think about our approach here. I want the mean body mass for Adeli, Gen 2, and whatever the other penguin is. I don't remember. What are the penguin names?
Adeli, Chinstrap, Gentry.
Chinstrap, thanks. Okay. All right, so I'm going to have to subset to each one of those and then find the body mass column and then take the mean. So I say Adeli is penguins, where penguins $species equals Adeli, comma. Great. Copy. Paste, paste. Chin strap. And Gen 2. What have I done?
Basically, only included the rows where the species was those respective. Filter out of
Made 3 data frames each.
Made 3 data frames. The first one is just the Adeli rows. The second one's just Chinstrap. The third one's Gen 2. Neat. So from each of those, shouldn't I just be able to say now Adeli $, body mass G, pipe that to mean? Yeah, but it gives me an NA. Well, good thing I've done question mark mean, and I know that I can say NA dot remove equals true. So there we have it. There's the Adeli mean body mass, 3,700. Copy, paste, paste. Chin strap, Gen 2. So Adelis and chin straps, basically they're about the same. Gen 2s are the big blubbery penguins. Okay. Those are the same means we saw in our plots when we looked at body mass G as a function of species. me know right now if what I've done there has confused you. Do you like it? It's okay. I don't love it. It's a lot of typing. But it works. Every problem in coding is like this. You can just break it down into simple English steps. Okay, Dr. Zahn wants the mean for each species of penguin. Well, I need to subset it to each species and then calculate the mean. Yeah.
Sorry, can you explain the na.rm? I was typing.
Okay, so if I say the mean of 1, 2, 3, and NA, the mean is NA. Why?
Because the na like messes up the
The whole thing. Now, fortunately, mean gives us na.rm. Should you strip the NA values first before calculating the mean? Yes, please. True. So na.rm equals true. Our mean is 2 now.
We
So
have to do that if the data didn't have any NAs.
you don't have to if it doesn't have any NAs. That goes for all those like summary statistic things, sum, min, max, mean, median. NAs will throw those out. You can say get rid of them first. NA remove equals true. Alright, so these 6 lines of code accomplish our task. That's fine. But I notice that I'm basically repeating the same code over and over. When you see that, you should think, for loop? Could I maybe do this with a for loop instead? Of course the answer is yes, or I wouldn't put it in that voice, right? So let's think about this. How's a for loop work in R?
You make up some kind of index and iterate over something.
For I in what?
A list of the 3, or not list, maybe a vector.
A vector of the 3 names of the species? Do I need to type those out myself?
You can probably do like unique.
Yeah. For I in unique penguins $species. If I just highlight unique penguins $species, there they are. Adelie, Gentoo, Chinstrap. Cool. What class is that?
Factor.
Factor. That's not characters. And remember, if I say that plus 1, oh, it's not meaningful for factors. I get NAs. Those are actually stored as numbers in the background, 1, 2, and 3 for the levels. So that's not quite going to work for us. Unless I, what? How do I turn something from a factor to a character? Oh, I don't know. Maybe like as character. There they are. Okay, so for I in unique penguin species as character. Alright, so what's the value of I going to be the first time through my loop? No. Adelie. Second time through the loop? third time through, chin strap. Okay, so then I do my curly brackets and I say, all right, what do I want to do for each of those values?
Do you want to do what you kind of did, where you
I want to do what I kind of did. I want to subset to where the species match that first value, and then I want to take the mean. So I could do SS, make a little subset inside of my for loop, and say subset is penguins, where penguins dollar species is equal to I, comma. All right, what's happening? Inside of my loop, the first time I go through it, I equals a deli. So inside of my loop, I'm going to create a new data frame called SS or subset. You can name it, I don't care what you name it. And it's going to be penguins, where penguin species is equal to a deli, all the rows. Well, neat. Then I can just do SS body mass G, pipe that to mean with NA dot remove equals true, and pipe that to print. So I want you focusing less on the syntax here, more on the idea of what's happening in the for loop. What are we going to get?
So you get the means of each subset per species, printed out one line at a time.
One line at a time, in the order Adeli, Gentoo, Chinstrap. So I run this whole loop. There they are, Adeli, Gentoo, Chinstrap. Well, that's nice. Well, it's kind of nice. We can see them, but what if I wanted to save those values?
create a vector and add on every time?
I can add on to a vector from inside a for loop, no problem. So I'm going to make an empty vector called means. How should I make an empty vector?
You can just write numeric over those parentheses.
I could say numeric. Done. We've got means. It is numeric. It is empty. So instead of printing it, couldn't I just say, take that and say means square bracket I is the body mass mean for that subset? What's means square bracket I gonna access, talk about? What's it refer to?
I mean, is it going to name one of the first element in the vector, the name of the
It sure will. Means square bracket Adeli will be 3700. So I'm going to run this loop. I left the print in there too, so it's showing up down here, but now means has been filled up. There are now 3 values inside of means. And what's really great is that if you just type means, hit Control Enter, it's a named numeric vector. So newsflash, every single vector out there can have names associated with it. A lot don't, it's just 1 through whatever. But you can attach names to them, no problem.
Mine says means not found when I try to do that.
Did you run line
You
code?
didn't run this. Well, you gotta first create an empty vector. See how I do means
Oh.
is numeric. So we gotta define it outside of the for loop. So I don't know, like, if you were to try to calculate the, maximum fatality of COVID deaths in each state, I don't know why you'd wanna do that, but in case you had to, coming up anytime soon, a for loop. Why not? For loops, anything in coding can be done with for loops. They're not always the fastest way, or the way that makes the most sense, but it's for loops all the way down in every language. That's pretty powerful. I know it's only 3 things, but if you had 300, you wouldn't want to subset 300 times and try to calculate. Just put it in a for loop, and inside the for loop, have it fill up a vector with your output values, and you've got them saved. Now, don't exactly forget what we just did, but I'm going to show you another way. Since we've got tidyverse loaded, we now have access to several packages, one of which is called dplyr. Because it's like a pair of pliers for data. It's your data plier. Right. Now, I want you just to watch this code. You can type along if you want. I'm going to take penguins. I'm going to pipe that to group by. And I'm going to say species. And then I'm going to pipe that to summarize. And I'm going to basically give it a formula to do some summary statistics for me. So I'm going to define a new variable, mean body mass equals the mean of the column body mass G with na.remove equals true. Even easier than a for loop.
So for loops are like versatile.
For loops are super versatile. You can do whatever you want. But for very common tasks, you've got helper functions. It is basically all the time when you're analyzing data that either you or somebody else is going to say, what's the mean of each species? Right? And there they are. What I've done here is I've taken my data frame and I've added a grouping variable and I've said species. Right? I want you to pay attention to each species separately. And then, now that you've got this group, I want you to do some summarizing for me. And we just start defining variables. I said mean body mass is the name of my variable I want to add to this new output table. And to get that, I want you to just take the mean of a column called body mass G, making sure to remove any NAs. Okay. If I go up to group by species and put comma sex, what do you think is going to happen without running it?
Species and sex within the species.
It's going to group by species and sex, so there'll be Adelie male, there'll be Adelie female, Adelie NA, right? There's still some NA sexes in there. And then our summary is going to look like what? Whoa. Since it groups by two variables, it's paying attention to all possible combinations of species and sex. So it's going to calculate a separate mean body mass for Adelie females, Adelie males, and Adelie NAs, which we actually don't want, but okay. Neato.
So where did we, are we not using dplyr yet?
This is dplyr, yeah.
So do we not have to type in dplyr?
Since we said library tidyverse, you don't have to. Group by and summarize are dplyr verbs.
Okay.
There are 7 dplyr verbs that we're going to learn. Well, I would like to add some more summary information. So I'll put a comma right at the end there, and inside my summarize, I want to make a new variable. What other thing do you want to know about the body mass or whatever of these penguins?
The max.
Let's do the max. Max body mass equals, and what should that be? How do we calculate the max body mass?
It's called max.
Yeah, it's that's right. The max body mass G NA dot remove equals true. So we're building ourselves, and this the output here is a data frame. So we could then pipe this into a ggplot if we just wanted to like see the mean and the max body mass. And you can call these variables whatever you want. So I'm going to rename this one fattest penguin. There you have it.
So if we're doing mean and max, can we just do like summary for all of them?
No. These have to evaluate to a single number.
Okay.
So you can do min, first quartile, median, mean, max, third quartile, whatever you want, but it's got to be a single number because it's got to fit into a single spot in your data frame. And I say it has to, it doesn't actually have to, but for this class, let's make it have to. Because you could have a column of data frame where everything in there isn't a number, it's its own separate data frame. It's real meta. Anything else you want to do with our summary here?
Do something more.
Ooh. All right, if I had a gong, I would ring it. This is a data frame. So we can pipe it further. Pipe. Time for a new dplyr verb. You've learned 2, group by and summarize. They always, for our purposes, are going to go together. If you're grouping by, it's so that you can summarize. You can't summarize without grouping by first. So group by and summarize are little friends. But we got another one. A new dplyr verb called arrange. What do you think it does? Sorry. Yeah. It arranges your data frame. So you tell it a column to arrange by. If you give it a character or a factor, it does it alphabetically. Give it a number, it does it numerically. So let's find the fattest penguin. So arrange fattest penguin. It's that simple.
Why can I do both? Because as it arranges one, the other one.
So this is just a sorting feature.
You invert it.
To invert it, it's kind of annoying, but we wrap fattest penguin in DESC for descending order. All right, so male Gen 2s are the fattest penguins. And then the female Gen 2s, and then the NA Gen 2s. And female Adelies are the smallest. All right, so far, dplyr verbs, you've seen group by and summarize, and you've seen arrange. We ready to move on to a new verb? I'm ready. So stop me if you need me to stop. Filter. What do you think filter does? Filters what?
The data,
By
what you tell it to.
what you tell it to.
Give me.
We've got 2 dimensions in this data frame.
You could get rid of
Could you get rid of the rows of NA?
Rows. Filter filters rows. Okay. So it helps us select the rows we want to pass on to the next step. So if I wanted to get rid of the NA stuff in my arranged, summarized, grouped data, where would I stick a filter in this chain of commands here? Hmm?
Row 3. There's like the number of the row or like Gen 2.
What I want is to get rid of the NAs here.
Yeah. So there's on the third row there's an
Yeah, but I don't want to go by row numbers. I don't like that. And Brittany, when you said 6 at the end, that was a row number. The order or column number, the order of columns can change. It's always better to use their name or a true false statement. So I don't want to have to know ahead of time that there's an NA on row 3. I just want to get rid of them wherever they are. So I'm going to do it before group by even gets in there, because I don't want to group by sex if NA is one of those sexes. So penguins, filter. How's this work? Any guesses?
What is the
NA.
is small?
is not
Not is NA what?
true.
The species.
No. Sex.
Or the sex, sorry.
And then I got to make sure to add my little pipe there so it goes on down. Remember how I said true false questions are actually really important all the time? Filter works on true false question based on column names. So here I'm saying filter all the rows. This is the ones I want to keep. That's what filter gives you. You give it whatever is true, it keeps. Not is NA sex. So I'm saying look in the sex column, find all the ones that are not NA. Those will evaluate to true, so we're going to keep those rows.
So this is similar to just to writing penguins open bracket.
Penguins, $sex, not is NA, that, oops. So
I like the filter better. 'Cause
this
usually
statement
it's twice.
is the exact same as that. If you have more than 1,000,000 rows of data, this is much faster. Like it will run faster on your computer. This has extra overhead, but it's worth it because it's more readable to me. And very seldom are you, as an undergrad, going to have more than 1,000,000 rows of data. Doesn't matter. Yeah, Laura.
So this is easy, like to figure out that it was in sex because we have 8 rows. But what if we had so many rows that we don't see any NA? Like, how do you know that the NA is gonna be in sex?
Oh. So we can check it by saying penguins sex unique. So that'll sort through 1,000,000,000 rows for you and tell you all the unique values. I see some NA in there. If you want, you can just do library or install packages skimmer, and here's what you get with skimmer. Is it skims your entire data set. And this is just another way of like looking at stuff. Variable species, the number of missing values, 0. Island, 0. Sex, 11. We've got 11 rows with missing information. Those will be NAs. The completion rate, right? So it gives you like a look at each variable in your data set, which can be really nice. So that's a quick way that I like to do when I'm like get a new data set and I want to know where's my stuff missing. Skimmer skim.
When we do install that packages, the package goes in quotation.
So I just always click on the install button here and say skimmer. But yeah, the package name does go in quotation. Skimmer's nice, but that whole package, that's basically all you get from it is this skim. It can be nice. So hopefully that answers your question on how do you know if there's NAs around. You basically just have to accidentally find out or go looking for them to start with. Okay, so taking penguins, only keeping the rows where sex is not NA. Then I'm going to group by species and sex. Then I'm going to create my summary with my 2 new variables. And then I'm going to arrange in descending order based on the fattest penguin. Yay, all the NAs are gone. Should just have our 6 rows, and we do. So I don't know if you were trying to calculate the maximum fatality rate for each state
Order them in.
in case you needed to order them or something. Maybe this would be useful. You could do it one state at a time by copying and pasting your code 50 times and changing the state name. You could do a for loop and have it fill a vector for you. Or you could be a civilized human being. And we call this tidyverse style coding, right? The one above here, this is base R. And it works just as well. And it actually computes a lot faster if you're working with big data. You need to know how to read it because you'll see it pop up and square brackets aren't going away. But if you've got tidyverse loaded, you can start chaining things together to get the output you want, tweaking at each step. Yes?
So can we name all this code whatever test
Well, we could. And this is what our output is. It's a table, a data frame, 6 rows, 4 columns. We could ggplot from that. We could just pipe this right into ggplot. So we could then say, boom, ggplot, aesthetic. What should be X? What should be Y? What should be fill? What should be color? What should be what?
Could we have sex and species as a combination of X?
Only if you put 2 aesthetics, so one's got to be like X, one's got to be fill or color or line type. Or okay. Species is X. Y equals fattest penguin. And remember, just because we're working with penguins data doesn't mean we get to use their column names. We have to use the ones that we created up to this point. Right now, these are the only column names we've got to plot from. Fattest penguin. Fill equals sex plus geom call. We'll do a column plot here. Call it good. Yeah. Inside of geom call it says position. Position equals dodge. Ooh, that's nicer. Rather than a position stack. So now we kind of have both of them on the X. So there's the fattest penguins in each of our categories that we made. Okay. Well, I kind of like Lauren's idea a bit better. Rather than piping into ggplot, I think I kind of want to save this as it is. And what did you want to call it? Test, sure. So I'll just send it all into test like that. Okay, so now I've got test. The reason I want to do that is because my chain pipeline is getting a bit too long, a bit unwieldy. Maybe I want to run some stats on test, not just plot it. So I'm going to save it, kind of like intermediate. And here it is. Behold, test. Great. Species is a factor, sex is a factor, mean body mass is numeric, fattest penguin is integer. Okay. The reason I'm talking about this is because I currently don't like them being in that order. Just because I'm going to be picky. I want Gen 2 to be first, and then Tinstrap, and then Adelie. Basically in descending order from the fattest penguins to the skinniest penguins. How do I rearrange that x-axis?
So take away the descent in a range.
Now descending, oh, I see what you're saying. I do want it in descending order. But, I mean, let's look at our, at test here. It's got Gen 2, then Chinstrap, then Adelie. But my plot,
Does the plot automatically do alphabetical?
the plot will absolutely automatically reimagine this factor of species. And I have to say, species, I know you may be a factor, but I want to set your levels a bit differently. I'm going to put them in a different order. So let's look. We've got test dollar species. There's my 6. Here's the levels. They're in alphabetical order. So that's the order they're plotted in, right there. How do you think I can access the levels of this vector? If you were just going to guess, what function would let us access the levels? The levels of. All right, so it really is, it's levels of that. The levels are a character class, and it's saying Adele Chinstrap Gen 2. Great. Okay. I don't know. How can we overwrite them with the order that we want?
So can you do aesthetic and so
Not
inside the
not
parentheses?
ggplot yet.
Not yet.
We're actually going to have to fix the levels into the order we want. We're going to have to overwrite them.
Would we use a range?
A what?
A range?
Nope. We're just talking about 3 words. That's our levels. The levels of test species is Adele Chinstrap Gen 2. And we want to say, no thank you. They should be Gen 2 Chinstrap Adele. How do we do that?
Looks like you make them into a factor.
Gen 2. Chinstrap. Adele. We've done that before by creating or overwriting a column in a data frame. We can overwrite the levels.
You didn't just replace the names, but didn't change.
I actually, since I sent this vector to the levels of that species, it actually replaced them. So if I run that again, look at the levels now.
But
This gave us access to.
Yeah.
This is an accessor function. So we can absolutely overwrite to the levels of that, and it will work.
But it's not going to screw up data is associated with what was a deli. It's not going to.
No, they're still in the exact same order
Okay.
that they were plotted. All we've changed is the levels of the vectors.
How do you do that with levels where you have like 50, 60, 70 levels?
Okay. 50, why do you say 50?
No reason.
Okay. Well, you would just want to access which ones you had. So, for example, you could override it with any vector that's equal length to the levels. And so if you don't want to have to type them out, you just look at them and you say test species, okay, unique, there they are. So as long as you've arranged that in the order you want first, you can go for it. All right, so we've overwritten our levels. Overwrite levels of a factor with new order. Now I can take test, pipe it to ggplot. Gen 2 Chinstrap Adele. Great. Okay.
Mine says, I want to try doing the locals test
Okay, so we've got group by, arrange, and filter. That's enough to learn in one day. I'd like to see you before we leave. Yeah.
So with that graph, when we switch the levels, it doesn't change the data with it, does it? Or should it? Because Oz, we like have the gym 2 and the Adley, and they just switch names. They don't actually switch like graph to graph.
Oh, a deli's bigger.
Yeah.
That shouldn't be.
Yeah, that's what I was kind of saying earlier.
Mm.
Actually.
Okay. So let's do this. I'm gonna save this little. Good catch. I'm gonna reset test. Levels of test. A deli, chin strap, Gen 2. Okay. Here's the actual clean way to do this. So we're going to set a factor. So for setting a new factor class object, this is just like saying numeric. We're going to say factor, and we'll feed it test species. And there we can reset our levels. Levels equals C. Gen 2 chin strap deli. Yes, that's better. So test species shall now be equal to a new factor variable, which is test species where we've changed the levels. So we're going to overwrite test dollar species with itself in a new level factor. And that worked. Okay. That makes sense?
So basically, by putting the levels in the order you did, it's going to automatically say, oh, Gen 2, you're 1.
Mm-hmm.
Strap, you're
Gen 2
2.
is 1. Yeah, chin strap is 2. Resetting levels comes in handy basically in two places for introductory R. For rearranging x-axis when you've got factors, and for changing which level becomes the intercept in a linear regression, which we're still a few weeks away from. All right, now I want you to show me something fun with filter. I want penguins where sex is not NA and where the penguin body mass is greater than 4,000. here's my filter statement. Remember, your filter statements always have to include one of the columns, because that's what you'll be filtering on, and then a true-false expression about that column. So not is NA sex, and body mass G greater than 4,000.
What's the reason not just using a comma instead of?
Comma gives you both, and you could replace with or. Looks like I got 167 rows of some big old penguins that don't have sexes NA. Okay? And we can keep going with our ands inside of there to really drill down. And let's say year is equal to 2007. All right, so those are the big, sexy penguins from the year 2007. So filter lets us pick rows, and it's always all about true-false. It's no different functionally than doing it with the square brackets, but to me this is easier to read. And it works well with the pipe. So enjoy finishing exam 1. Hopefully this helps with some things. I look forward to doing a git pull on all of your repositories on Thursday, right as class is starting, so I can see the life leave your eyes when I get nothing from you. Feeds me. Questions?
I have a random question.
Yes.
Do packages install to like our project, or do they get installed to our computer?
To your computer.
So do we need to like do install packages when we turn in anything to you? Like
No.
our script? We don't need to.
No.
Just like.
In fact, it's actually considered pretty bad, like, manners to have install packages in your code,
So we just do like.
because you
library
don't,
and
like, yeah, do library.
Okay, I just wanted to make sure that like I don't want you to have to install.
Yeah, this is bad manners because if I start running your code, it's going to start installing stuff on my computer without permission. So do that on your computer. When it comes time for your actual code that you're turning in, it's just library tidyverse. Yeah. If I don't have it, I'll install it. But
So how do you push the, like, a certain project to a file on your Git repository rather than just right to your, only to your repository?
to a file.
So like, yeah, if you have like a folder in the repository, how do you push it to that folder in the repository?
It's automatic. It does that.
Well, when I do, it just goes to my repository, like not in the folders.
Your online repository will exactly reflect what it looks like on your computer. So that means your computer project isn't set up well. If you want it to be in a specific folder, you need to move it into that folder in your computer.
Not a folder in my computer, a folder in my repository.
That's on your computer, right? You're talking about this repository like it's a magical unicorn floating in outer space. It's literally just a copy of a folder on your computer. And so whatever is in that folder on your computer, your repository, is what shows up online.
Okay. So for example,
So you just got assignments sitting out in Data Course Knowledge.
yeah.
That means that that's how it looks on your computer too. So if you want
If I
assignment
want-
4
if
to
I
go
want-
into assignment 4 subdirectory, you need to fix it on your machine. So this is a cold reflection of hate that you're seeing in the mirror. It's you the whole time. So get in there and just in your like Finder browser and move things to where you want them to be. Add commit
And then
push,
it'll reflect.
add commit push, and then it'll reflect it.
So what happens when a submodules or not looking submodules? Is that just
Where?
setting it up wrong when I'm, I was sending you Teams messages about it.
All right, everyone, anything else? Last 5 minutes, yeah.
Just a quick question. So when I make a new like off script file while I'm inside a project, that shows up always in that project.
Yes.
Okay.
Now, I do that all the time. So I'll save this one, and since I'm inside of Data Course On, you know, I'm gonna put it in notes, and I'll call it week 5. Are we on week 5?
Yeah.
Whoa! Day 1. I save that. Great. If I want to push it to my Git repository online, here, let's make this bigger. I look around inside of notes. There's my file. Great. Git add week star, that added everything. Git status, those new files. Git commit, add some notes. Done. Git push. The end.
So if you would open up then like the R project that's connected to that file will show up as well.
Yeah, absolutely. And so let's find it in my repositories to make sure. Data course is on. I got some notes there. There it is. Today's script. And I could close this out, change my R project to a different one. Alright, now go back in and say, alright, I'm opening Data course is on, I'm getting ready to grade week 5 day 1.r. Control O. There it is.
So now that I've moved all my files on my Finder, how do I update it on my repository?
What I just did. Add, commit, push.
Like git add what?
Everything. The files where they are now.
You can type git status.
It'll show you the.
Anything that's on there that you want to keep.
Look, it's showing me the exact path to the folders it doesn't know about, things that are changed.
And then from there you just do git add.
Yeah, so if I wanted to add my data directory, it would be git add from here, .. /data. We got 4 minutes.
How did you say you do it using the factor when you have like 50 different things?
You want to have some kind of command that will order it for you.
Yes.
Whatever you want. But you don't want to type it in manually, of course.
Yeah.
But you can have some command that will order it for you.
So if you can get a data frame ordered the way you want it, and then take that data frame and do $ the name of the column that you want, I don't know, like state or something, it's already going to be in that freaking order. It's just a vector in that order, and so when you assign the levels, you just say this vector. Penguins, arrange, body mass G. I'll do that in descending order. All right. Library, Palmer penguins. Library tidyverse. Cool. So now I've arranged it in descending order from the fattest to the skinniest penguin. So I'll call that test. Test dollar, oops. Species. Unique. Look, Gentoo, Chenstrap, Adeli. Cool. So test species is now going to be factor test species, and the levels is going to be test species unique. And I'm done. So I arranged it, I pluck out the order of those things, and I pump it in as my new levels.